Hi, I'm Bob Henry, Product Manager for Epilog Laser. With over 35 years of laser system design and manufacturing experience, we're really excited to introduce our newest model to our lineup, the Fusion G100 Galvo-based laser system. Like all laser systems we manufacture, the G100 has a 7-inch touchscreen display, has the onboard camera system, integrated exhaust control, USB network and Wi-Fi connectivity. Also included with the Galvo-based machine are both the f-theta 163 and 254 lenses that give us a 4x4 and a 6x6 marking area. We have an oversized table to accommodate larger parts inside the machine. Large viewing window with motor-driven non-pneumatic automatic door. 2-point movable exhaust inside the machine for great evacuation of particulates. And of course, like any Epilog system, we can use non-proprietary software for graphic creation. CorelDRAW, Adobe Illustrator, InDesign, Inkscape, BarTender, EngraveLab, and many more. Really excited to show you the machine today. Of course, we're going to do a tour of the machine. We're going to talk about the software, and we'll be running some jobs. So with that, let's get started. We're going to start our machine tour at the control panel on the laser. Again, like all of the Epilog laser systems we manufacture, it has a 7-inch touchscreen display. Really useful feature in this machine to select the job that you want to run. So if you want to pick a job, you just simply highlight it, and then we can run that particular job. This is our jobs list at the top. So if we click on that, that gives us the list. We can delete the job if we wanted to. This is the settings that allows us to go into the controls of the laser, change things if we wanted to. This is kind of where all the programming is done, where you set up the network connection, the USB connection. All those features are set there. Back to our jobs list, we'll go down to the kind of the primary functions for the laser system. Of course, this is the start and pause button. This is the reset button. This is the toggle to open and close the door of the machine. So we just open that up, and then to close it, we hit the close button. I should note that when we start a job and the door is open, the door automatically comes down, and then the job will start once the door is securely closed. This is our focus button. This allows us to raise and lower the Galvo platform to get in the correct focal plane for a particular part that we're going to be marking on. We'll show you this function when we get into processing some materials here in a little bit. This is the red dot pointer. You can't see it in the machine, but this is a really useful tool for relocating a home position within the machine. If you wanted to use our center engraving feature to set a new location where you want to mark, you use this red dot pointer along with the joystick to move the red dot in the machine to a fixed location where you want to start a new job. Joystick control here, this allows you to move the gantry around, including that red dot pointer to set a new home position. This also works really well, of course, with the focus command to raise and lower the table. And then the last button that we have here is the trace function. Once we've sent the job over, we have our material placed on the bed of the laser. We want to preview the location of where that mark is going to go. We hit the trace function, and that gives us a perimeter box around the outline of where we're going to be mark or engraving. And then you can make sure that your artwork is going to be placed properly. With the focus button, we have many ways that we can actually focus on the material. You'll notice that when the focus button is engaged, we have the crosshatch, the red lines in the X pattern there generated by the laser and the Galvo. You'll notice the little satellite lobe here. When we have material on the bed of the laser, and to get into the correct focal plane, we simply raise and lower the Galvo platform until that red spot intersects the middle of that crosshair. Once we have that, we know we're in the correct focal plane. We can also use the integrated focus gauge. This is attached to the side panel of the machine. We simply hang this on here and then raise and lower the table until the material touches on that focus gauge. We have separate gauges for both the f-theta 163, like you see here, and then of course a longer gauge for the f-theta 254. And those are conveniently mounted to the side of the machine here, so you can easily store them back in place. You can also focus by manually measuring the height of the part, and then with the focus installed, or focus on rather, we can raise the Galvo platform to the height of that part and set the part height there. So now we would be in the correct focal plane for whatever part we're going to mark if it's 1 inch in height. Moving on, we'll turn the focus off. We'll now show the relocatable home position feature. So with the red dot pointer on and the joystick enabled, we're able to move that red dot to a particular location. That can now act as our 0 position to make that location be the center of our engraving or the left of our engraving, the top or the bottom of our engraving. Really handy feature for those odd shaped parts where you need to use the control of the relocatable home to find your new home position. And then the trace feature that we talked about, you can see we've just got a bounding box that goes around the image that we're going to be engraving. We mentioned the 2-point exhaust. I wanted to show you how the machine is exhausted. In the back of the unit, we have this plenum here. We can open and close this. So with this open, we get a nice kind of back sweep sort of exhaust through the back of the machine with an exhaust fan or filter system hooked up. If we close that, then we have 2-point exhaust where we can articulate these arms and put it right at the work surface to get maximum extraction of particulates and vapor coming off during the marking and engraving process. As you can see from the table here, it's kind of an inverted T shape. We tried to maximize the amount of space available in the machine to accommodate larger parts. We have threaded holes in here. They're on 25mm center with the intention to allow our customers to create fixturing throughout the back of the machine all the way to the front of the machine. Our rotary device will sit in this location here. You can see over to the left we have an electrical connection for the rotary to be installed. The rotary can also be installed at the back of the machine to have parts extending out towards the front of the machine. Included with all Fusion G100 machines are an f-theta 163 and an f-theta 254 focus lens. Again, this gives us a roughly 4-inch by 4-inch marking field, and the f-theta 254 gives us a 6-inch marking field. We're really excited to be able to offer both lenses with every machine. Not an optional purchase. Again, they're both included. The 254 and the 163 optics, those are positioned into the Galvo platform here. What I want to point out is this sensor here. This will detect which optic is installed and then automatically give you feedback to our software to give you either a 4-inch marking page or a 6-inch marking page. So a really neat feature here that automatically detects which lens is installed. So I've just installed the f-theta 163 lens. You'll notice in the back here that we have one of these two lights illuminated. The green light is lit up here. If we had the 254 lens installed here, both of these would be illuminated, both the red and the green. In addition to the lights on the Galvo platform indicating which lens is installed, we also show it on the display panel. Here you can see it says F163, indicating that the 163 lens is installed. If we change that out and install the 254, of course it would say F254. All of the Fusion G100 machines have an emergency stop, and for those customers that need to control access and operation of the machine, a key start. We're going to spend a little time talking about the software, but first I want to send a job over to our software. In our software is where we have our camera view. It allows us to use that camera for artwork placement. So let's start again with CorelDRAW is what a lot of our customers use. You can also use a variety of different software programs, BarTender, InDesign, Inkscape, EngraveLab software is commonly used as well, Adobe Illustrator. Many software programs work with the Epilog laser systems. It's a really handy feature for our customers that have existing software and they don't want to have to migrate to a proprietary software that most Galvo systems are driven by. So we're using CorelDRAW. We're going to just print over a basic image here. We've got it imported, or rather loaded up on our screen. You'll notice here that we have a variety of different types of output devices. Here we're going to select the Epilog engraver and then simply click on print. This is going to put the job into the Epilog software suite environment. You'll notice on screen that the graphic is larger than the 4x4 field that we see here. The visual that you see on the bed of the laser is our workspace. So we can simply click on this and then make this smaller to fit in the space that we want it to be in. So we're going to put it right there. Before we run this job though, I want to show you some features in the Epilog software suite. Here, I'll start at the top, the machine name. We're going to be working with the MOPA 60 watt. This is the 4x4 field. We call it 3.15. That's the IP address that we've established in the machine. Our customers find unique ways to name their machines. We like to use an IP address, but what's interesting here is that with any of the Epilog machines, you can run all of those machines from one computer and use the same software to run all of those machines. For instance, if I wanted to use our Fusion Pro 32 machine, I don't have it hooked up, of course, so I'm not going to have camera view, but this is what it would look like in that environment. So here we're going to go back to the MOPA 60 watt. Our camera view will come up here in just a second. So there's our object. We've got the right machine. We can give it a different name. This is something that I've been encouraging customers to do, is change the name of the job. If you don't have a name, if you sent it from CorelDRAW, it's going to show up as untitled. I personally have sent many jobs over to the laser system. Those jobs stack up in the job queue at the machine, and they're all called Untitled 1. So sometimes I get confused which job I'm running. Fortunately, at the control panel on the machine, we have a little thumbnail sketch that you can use to identify the right job that you want to run. So again, I would encourage you to change the name to the job that you're going to run here. All of these functions that you see over here control the graphic. Here's the size of the graphic, the boundary of the graphic. And if we click on this graphic specifically, here we can use some rotate functions. If we wanted to rotate that image by 45 degrees, we can do that. We can change the size of that object as well. The Control Z, always a great tool to back out of whatever you've done there. Here you can set the contrast. If you wanted to have a little bit more viewability up there, you can see that we can change the contrast here. It shows that a little bit darker, but if we click on this or click off the contrast button, we get a better view of that object. Especially difficult to see on black substrate like the anodized aluminum that we're going to mark. Other things I want to show you in here, we have an autofocus feature. So if you wanted to set the thickness of the material, you can set that here, and then the Galvo platform will automatically move to that height. I have gotten in the habit of just using the focus finder in the machine or measuring the material thickness and then setting the focus based on that thickness at the machine. Here we have some different processes I want to talk about. We have engrave, hatch, or vector. The hatch is what most of our customers are going to use on the G100 machine. This gives us the ability to set a variety of different hatch angles. For deep engraving, it's a wonderful tool to set different hatch angles to allow for better, more consistent deep engraving. The engrave function is new to the Epilog G100 machine. It's a really cool feature. This is what you'll use if you want to process bitmaps or photographs. It emulates essentially a flatbed laser where the gantry, the Galvo laser is moving left and right and approaching the front of the machine in the X or the Y dimension. So this is what you'll use for doing bitmaps and photographs, the engrave function, but generally you're going to be working in the hatch function. So here you can set the number of cycles, how many times you want to run the job. You can set the offset here if you wanted to offset to achieve a different type of mark by defocusing on some material. You can specify the thickness or the height of that offset that you want. This is a really cool feature here. This is called an array. This allows you to set up any number of arrays. So if you wanted to set a hatch angle at 15 degrees, at 15-degree increments and have it go around to a 360-degree circle, you can set that up in here. Really handy feature. A lot of our customers are going to find great utility in that. That's going to be a nice one for doing deep engraving. If you have to get real deep into it, you can set up, again, any hatch angle that you want, and also how many passes that you'd like or how many steps that you'd like along the way there. Here we can add hatch patterns. So here we've got a hatch, we've got a speed, a power, a frequency, and a waveform value. Good time to talk about waveform and frequency. So with the G100 machines, we're offering a 30-watt fixed pulse duration laser, a 30-watt MOPA laser, and a 60-watt MOPA laser. MOPA is an acronym for Master Oscillator Power Amplifier. Essentially gives us the ability to control the pulse duration with a MOPA laser. So we have 16 different pulse durations that we can control with the laser. The 30-watt fixed pulse duration does not have that pulse duration capability, or the ability to change that pulse duration, I should say. That's a fixed pulse duration laser. The 30-watt fixed pulse is going to be a great laser for some basic surface etching or some deep engraving into material. The MOPA lasers, because we have the added control of defining the pulse duration for a particular material, gives us the ability to do different types and a greater range of different type of marks and engraving into different materials. So here we've got a MOPA laser that we're using. We can set up different hatch patterns. This is our import function here, so we can import parameters, and this is built into the machine. When our customers install the software, all of these presets are already built into that software, so they can go into the job settings, load those up for the particular material that they're working with. Of course, we don't have all of the presets for every material out there, but with our software, we're able to allow our customers to add to that and name that and organize those how they would like to. So here we're going to do some anodized aluminum marking. So I'm going to click on the ano white mark, and then I'm going to import that. You'll see here that we have two different hatch patterns that are already preset. We're running at 100 speed, 35 power, 1 frequency, and a waveform of 6 on the first pass. We also have a line spacing of 1.5 thousandths of an inch, 0 hatch angle, and then 1 pass there. On the second pass, we're doing the same thing. We're just changing the hatch angle from 0 to 90 degrees. The second pass on anodized aluminum really does a nice job of brightening up the material, the surface of the engraved area, to give it that nice bright white look. We have some different types of hatch angles. We have sweep here. We can also change this to unidirectional. This is going to be a little bit slower than the sweep pattern. Also an outline. Oftentimes for deep engraving into material, you'll set an additional outline pass at the end of all of the hatch patterns that you have that goes around the image and does a nice job of sort of cleaning up the edge. But here we're going to run the standard sweep pattern, by far the best one to use for this type of work. And then once we're satisfied with all of this work that we've set in here, all the parameters, we simply click on the print button. So we printed this job over to the laser system directly. We can also send it to our job manager. The job manager is a great component of our software suite. The environment that we're looking in here is the dashboard, we call, but the job manager is a really useful tool for those companies that need to organize their graphic files and keep them organized, maybe material specific or customer specific. Here you can see that we've got some main tabs through the manager. We'll just do a quick tour here. I mentioned previously that you can hook up any Epilog laser to the software suite and run any number of machines from this environment. You can also organize your jobs here. So when we send a job over, it comes into the temporary file here, and then we can move this over to different categories. So we've got a couple Western Supply and Zen Corp companies that we made up, but we've of course included some graphic files that those companies are going to use very often. And then here you can set up subcategories for material or a job or again a company. So a lot of different ways you can manipulate the job manager for job storage here. Also in the job settings, these are all the presets that are populated in the machine, but you can change these if you wanted to. If you find that your particular material looks a little bit better with a slight change to the laser parameter, you can go into this environment and change it here as well. So we give lots of powerful control over the work that you're doing at the laser through the job manager. So keep this in mind, great tool for storing jobs, manipulating jobs. If you're just doing basic stuff, more one-off, then you're going to spend more of your time just in the dashboard suite. With the job sent over to the laser, again, we have a list of jobs that we've sent. The last job that you sent over always comes up on the top of the list here. There's the job we want to run. If we wanted to verify the laser parameters that we're going to run, we can click and hold on that job and then click on the arrow, and this gives us all of the laser parameters associated with that job. We've got speed, power, frequency, and waveform. and then it's listed for the second hatching pattern as well. So a great way to kind of verify that the laser parameters that you've sent over are indeed what you want. And then just go back out. And now we're ready to do a focus function on the material that we're going to run. This graphic we're going to engrave on some black anodized material. Black anodized is sometimes hard to see with the red dot pointer, but we'll put it in place and we're going to set the focus here. So I'm going to press the focus button on the control panel. You can see that we've got the X created by the Galvo, the red diode, and then you can also see the secondary lobe coming off there. We're just going to move that until it's center line on that crosshatch, and then we're ready to go. You could also measure the thickness of the material and then simply program that into the control panel of the laser, or you can use the manual focus gauge where you just hang it on here and then raise and lower the table until the gauge touches on the material. So different ways to focus, really handy features. I think our customers are going to find that they're going to find one way that works well and probably stick with that. For me personally, I like to measure the material and program it here, but this is a really handy feature, really fast to do it as well. So let's turn the focus off and then we'll run a trace feature just to make sure. I'm going to move that so you can see what that looks like with the trace feature, kind of a bounding box around the image. And so I'm just going to line it up where I want it to go in that space. Of course, if I hadn't moved my material and I sent the job over, I was using camera view to locate where that was going to go. But because we've moved the material, we'll have to reposition it here. So once you're done with that, we'll go back to the job menu and then we're going to run the job. As I mentioned, when you press the start button on the control panel, the door comes down and then the job starts. So here we go. When the job finishes, the door will automatically open. And there we go, our first project on black anodized aluminum. Another really nice feature with the Epilog software suite in the job manager is what we call the generate function. This allows you to set up an array using a variety of different laser parameters to determine the type of marks that you can get on some different types of material. So again, under the Jobs tab in the Job Manager, we'll click on Hatch here. This is the array function. We can give it a name if we wanted to. We can define how big we want the individual cells to be. I'm going to make those 0.15 in size, 1.15 inch in size. We can also change the number of rows or columns that we want to run here as well. I tend to set up as many as I can put in there, so that's a 10 by 10 array. So we'll set this up for 10 by 10. And then we can set two variables and a number of constants in here. So for this sample, I'm going to keep the speed at 100%. I'm going to keep the power at 100%. I'm going to change the frequency variable in the X dimension from 1 to 100. And then I'm going to change the waveform, make that a variable in the Y dimension from 0 to 15. We'll set this up so we've got 0, 0, 1 line spacing, a 0 degree angle, and then 1 pass should be fine. And once we've got that set up, we just click on Save, and then there's the job. Then we'll print that over to the machine, and then we'll go to the machine and run that job. Back at the laser, we can see that job that we just generated is now populated in the display panel here, and so we're ready to run. The generate array that we're going to test is just on some stainless steel. You'll notice that I put some posts in here. These are little fixturing posts that thread into the table here. Really handy for fixturing up certain types of jobs. We include some of these with the machine when we send them out, knowing that our customers are probably going to use a lot of different type of fixturing in this machine. So here you can see that we've got the trace on for that job. That's where the image is going to be produced on the material. So with our job in place, we like the location, we are ready to go. Once you've run the array, you can look at the map and then go back to the software and bring up the row and column that you like the mark of, and then bring up that particular hatch and look at the laser parameters that were applied for that particular mark. The next project we're going to run is a stainless steel battle axe. We have some really neat graphics that we're going to use for this particular job. So let's set up the artwork first, and then we'll put the object into the laser, do the focus, and then get to everything set up there. So the first thing we're going to do is select a graphic that we want to run. We've got a bunch of them on here on this page. Let's select this guy here. We're going to run him and see how this turns out. So we're going to go to File, Print, and we'll use Selection here. So we're just selecting the one that we have indicated there. There's our artwork, comes into the laser. You can see that the bed of the laser with our fixturing pins there. So I'm going to take those out, and then we're going to place our object into the bed of the laser, do focus, and then we can manipulate the artwork relative to the position of the axe while it's in there. So you'll notice a couple things here. We've got our fixturing pins in there. We'll need to move those out of the way so we can put our entire axe in here. And with the axe handle going toward the front of the machine, we won't be able to close the door. So we're going to just spin it around by 90 degrees and place it in this orientation. Try to get the marking field sort of under center of Galvo there. And then we're going to use the focus function to locate where we want that mark to go, or rather the correct focal plane. So you can see the red spot moving off the crosshair there. I want to bring that up right until it engages right in the middle. Once I'm satisfied with that, I'm going to print that job over to the laser. All right, in the software suite, you can see that we've got the job imported. You can see our axe on the bed of the laser. We've set our focus. We need to resize that a little bit, and we need to rotate this also. It's the wrong orientation, so I'm going to spin this by 180 degrees, and we do that through the Epilog software. So there's our graphic, and again, I can place this kind of wherever I want in that space. That looks pretty good to me. And then I'm going to import some polish settings for this. It's a really nice setting that gives us kind of a white polish mark on the surface of the metal. It looks really good. There it is, and I'll import. You can see that we're just doing one hatch there. It's 70 speed, 50 power, 40 frequency, and a waveform of 15. So if we're happy with that, we're just going to hit print. Actually, I'm going to give it a new job. I'm going to call it Viking. So when it shows up at the display panel, that's what it's going to tell me the job is. So we're ready to print, and then the job is transferred over to the G100. For our next project, we're going to engrave a Glock 9 slide. This has a really nice dark green Cerakote coating on it. So our objective here is to remove the coating and then provide a little polish to the surface of the metal. We've got kind of a decorative piece of art that we're going to put on here. We're going to put that just in this space here along the side of the slide. So you can see I've got one already set up in here, ready. It's already focused. We're ready for camera view. So let's go back to the computer and we'll set up the artwork there. Okay, we're back at the computer. And here you can see a live camera view of the slide on the bed of the laser. We're going to use the camera function in here and then take that image that we take a picture of here and import that into CorelDRAW and use this basically as a template to drop our artwork on there. Really handy feature in our software suite. So you'll see we click on the copy background image. So we click on that, and then we'll go back into the CorelDRAW or graphic environment, and we're going to paste that to the surface. So that's basically just a picture of the surface of the G100 with the slides sitting right there. So now we can import some artwork. After we've taken a picture of the image on the bed of the laser, we can import that into our software. And then here we move it back to CorelDRAW, and we're going to manipulate that to fit the space on the side of the Glock. You can see with the software we can kind of move that around and make it actually fit really closely to the shape of the Glock, of the slide. So we're just going to manipulate it around a little bit, make sure that we're not going to be overlapping anything or having the image spill off the side anywhere. That looks good. Perfect. Now we're ready to print this, so we can get rid of the background image or do selection, and then we're going to print this. There's our camera view, perfect placement using that tool where we import or export that photograph. And now we can go into our import settings. I'm going to go into the MOPA 60 watt, and I'm going to bring up the Cerakote 3, and then we'll import that. These are all the laser parameters that'll give us that nice mark on there. And then here we just click on print. I've already focused at the laser, so we are ready to run. Our next engraving project is going to be a simple data plate. This is kind of interesting though, and it's going to illustrate sort of the neat things you can do in our Epilog software suite. So you can see on screen here that we've got just a simple data plate. We have two colors. We've got a QR code that's red, and then the rest of the graphic is black. We want to apply different laser parameters to the red and the black, and I'll show you how to do that in the software suite, along with some other things. So you'll notice the page size here too is set to 4 inches by 2 inches. And so I'm going to print this job over. And when I click on print, we go into the software suite. You'll notice that the image is here. We need to move it a little bit, but you'll also notice that this pink area is outside of the engravable space. So that's based on the page size in Corel Draw. So we can make that engravable space bigger by just moving that out of the way. Now we've got the entire 4x4 field to work with. So here we're going to place our artwork. We want it, of course, a little bit right of the hole there. And then this is kind of neat too. So here we can apply different laser parameters based on color. So in software, I'm going to say split by color. And you'll notice that we've got the red and then the black. We also have some stuff that came over in that graphic image. This is common. Sometimes you'll have extraneous stuff that you can't see. So we can actually turn this off, just get rid of it, not worry about anything related to the unknown data there. Now we can go back in here and set the laser parameters for the red, which is the QR code. So I'm going to set this, I'm going to do this manually instead of importing. I'm going to set this at some values where we're going to get some deep engraving into that material. So I'm going to set that at 75 speed, 100 power, 1 frequency. I'm going to set that waveform high. That's the highest pulse duration. And then I'm going to add a hatch pattern there. When I add a hatch pattern, we populate the same data as before. The only thing I'm going to do different here is change the hatch angle. So we're going to do 2 hatch angles there. And then when we go to the black, I'm just going to do 1 hatch angle, and I'm going to go at about 50% speed, 100 power, 1 frequency, and then we'll do that 15 waveform. Keep it all the same, and then we'll give it a new name. We've got it called it the Western AV. So let's print that over, and then we'll go to the machine and get it started. So we've sent the job over to the laser. Let's do the trace function to make sure that we're going to be marking where we want. That looks really good to me, so we'll turn that off, and then we'll go back to the job, and then we'll close the door, and then we'll start the job. There's always a little metal debris that comes off the engraving. We just use a simple cloth to wipe that off. And we've got a nice deep engraving into that stainless steel. With our next project, we're going to mark on some plastic security tags. We've already got the artwork set up. In the graphic software, I'm not terribly worried about the location of the graphics relative to each other or the position relative to the tags that we're going to engrave. So we're going to do that in our Epilog software suite. We're going to print this job over there, and then we can do some manipulation there. So you'll notice, as we talked about before, that in the graphic software, if we don't have the page size equal to 4x4, we have this unprintable margin, but I can just move that out of the way to give us that full space. Next, I want to rotate the graphic by 90 degrees. And then here, I can ungroup those items, and then I'm going to select this group and move it into place. I'll do the same thing with the second image. And then with the third as well. That looks good. We'll import some laser parameters for this specific material. Import that. So we're running this at 100 speed, 100 power, 1 frequency, and a waveform of 3. And a little bit wider line spacing as well. This is going to be at 0.003 of an inch. I'm going to move these around just a little bit. And we're ready to go. So now I can just print this over to the laser system, and then we'll hit the go button and we'll start printing. This particular plastic marks up really well with the fiber wavelength light energy. To this point, we've been using common graphics software, but now we're going to go into more of an industrial type of application with BarTender software. The Epilog lasers, all of them, including the Galvo, work with a variety of different software programs, BarTender being one that's fairly popular, EngraveLab, Label Matrix. So here we're just going to set up a simple job and then put that into the software suite and then print that over to the G100 machine. So we'll start with just selecting a barcode. I'll click on this, and we're going to do a data matrix code, and then we'll just drop it kind of in the middle of the page here. Make it a little bit bigger. It's got a human readable of 1, 2, 3, 4, 5, 6. Of course, we can change those data in BarTender. You can import data from external data sources as well. I'm going to get rid of the human readable here, so I'm just going to take that off and go here to human readable and then none, and then I'll close that. So now we've got this barcode, kind of drop it in the middle of the page. I've set this up to have the 4x4 field that we're using in the G100 for the video work that we're doing today. So here I just click on print and then print, and then that populates into our space here. This is again the Epilog print driver. Here's where we'll set all the laser parameters. With that BarTender barcode loaded into the Epilog software, then we print it over to the machine. You can see we've got our camera view here. We're going to be printing on some black anodized aluminum security tag material. So here I'm just going to import some laser parameters that work real well for that material. I'll bring that up here, import, and then we'll send the job over. We've already focused, so we should be good to go there. And send the job over to the laser system. Go to our jobs list. I'm going to do a trace real quick, make sure we like the location. Looks good right in the middle of that disc. And then I'm going to close the door and we're going to run the job. There we've got a nice 2D data matrix barcode. Thank you for spending some time with us today to check out the new G100 laser system from Epilog. If you'd like to learn more about Epilog Laser, give us a call or look us up online, epiloglaser.com.